All right, so we're going to start off 1, 2 today. This one's called transformations of functions, meaning we're going to be looking at how graphs get moved. So this is a pretty big section for the rest of the year. In fact, I would argue these first two sections we do are actually really crucial, which is why we're going to spend a lot of time on. So this one here says graph this function for this domain. So we're graphing x squared from -2 to 2. And then it says also graph g, which is what happens when you transform it 3 units down. So it's asking us to do a few things. The graphs are already done on here, so I wanted to talk about those first. So the graph of x squared is a U-shaped or parabola-shaped graph. And when it's just plain old x squared, it has a vertex at 0, 0, and it's U-shaped from there. You'll notice they have points plotted on here. You'll see like the coordinate like 2, 4, because if you put a 2 into this, 2 squared is 4. So that's why like the coordinate 2, 4 makes sense on it. So that's the graph. And you'll notice when it says domain from -2 to 2, that's what they did. They only graphed it from -2 to 2. Technically, you could draw this where it continued out with arrows, but because they say just stop at -2 and 2, that's why it's dots there and there. So just graphing a specific graph from a certain number to a certain number. Then it also says the graph of g, which is, so this one here is g, the one on top here is f. G is the same graph, but translated or transformed 3 units down. So all that means is they took this vertex and they shifted it down 3 units. Everything else stayed the same. So again, this point down 3 units, this point down 3 units. Everything just got shifted down. You probably remember that concept from geometry because you definitely did stuff with translations and that kind of thing then. So there's a few questions we're going to talk about and look at here. So I'm going to kind of break this up kind of like a table. So our first equation, which is the f of x, that one's x squared. So I want to talk about a few key features to this thing. So one is I want to talk about what is its vertex. I want to talk about what is its axis of symmetry. I'll tell you what that means in a second. And then we're also going to talk about its domain and range. So we're going to talk about all 4 of those things for the f of x function. Then we're going to do the same thing for the g of x function. All right. So on the f of x function, plain old x squared, that is just U-shaped graph. The vertex, which is like the tip of the parabola or the tip of the U, in this case is at 0, 0. So we're just giving the coordinate of where the vertex is located. Now we've got a thing called axis of symmetry. So symmetry, if you remember what that means, symmetry is when you can draw a line down the middle of something and it's the same on both sides. So anytime you have a U-shaped graph, it has a line of symmetry going straight down the center like this. In this case, that axis of symmetry is the y-axis. It splits this perfectly in half. What we do, though, is because the axis of symmetry is usually a vertical line, and you're going to notice, especially down here, like graphs will move to different places. We want to give it by the x coordinate that it goes through. So this line is actually just the line x equals 0. Because, for example, if I were to say, where's the line x equals 4? X equals 4 would be a vertical line through 4. That'd be like right here. So when we talk about axis of symmetry, we want to give it as what x value is that vertical line going through. So you see some more examples, it'll make some more sense too. The domain we already know, they told us it was -2 to 2. That one's easy. And then the range, we just look at our graph, we can tell what the range is. So if we look at this graph, its range, the lowest value it reached was 0, and the highest value it reached was 4. So we'd say its range goes from 0 to 4. So again, tying some of the concepts from last section in with this, some of the new stuff. Now, what do we know about this g of x graph? Okay, it's the same exact graph, but just shifted down 3 units. The way you do that is actually really easy. You keep the function the same, and then you just add or subtract however much you want it to move it up or down. So in this case, if I want it to shift down 3 units, all I have to do is put a -3 on the function. So that's what the equation would look like for g of x. And then we can answer all the same things. What's its vertex? Well, now it's down here, so its vertex would be 0, -3, giving its coordinate. Okay, its axis of symmetry did not change because we didn't shift left or right at all. So it's still x equals 0 for the axis of symmetry. And then the domain also didn't move left or right at all. So the domain is still from -2 to 2. Nothing changing there. But the range is different. Because we shifted the graph down, it now goes to a different like low and high point. So the lowest point that this g graph reaches is -3. And the highest that it reaches is 1. So we would say this goes from -3 to 1. Okay? So again, just talking about some graph stuff. we're going to be working with this. This whole section's about this, and you're going to get pieces of it as we go. So now let's look at an example where they shift it to the left or right. So this one, same exact concept. So I'm going to do the exact same thing. So you say we've got this f of x function that's x squared, and we're going to talk about these four things. We're going to talk about the vertex, the axis of symmetry, the domain, and the range. So here's the super easy part. The f of x function is the same exact thing. The f of x function is this same one. It's just x squared. So all this information is going to be exactly what it was before. Its vertex is at 0, 0. Its axis of symmetry is x equals 0. Its domain is what they told us, -2 to 2. And its range, 0 to 4. All the same exact information from before because it's the same exact function with the same exact domain. But now they say, okay, this graph is now shifted to the right 3 units. How do we make that happen? What do we have to do to the function to impact that? This is the one that's a little bit trickier. So this g of x function, to shift left or right, you have to do it to the x value directly. So the way you do that is you put parentheses, and you actually go kind of the opposite of what you think. If you want to shift to the right, you actually put a -3 inside there. So again, when you affect the x value directly, that's going to shift it left or right. So actually a -3 shifts it right 3 units. If you put a +3 here, that would shift it left 3 units. If you put a +7 here, it would shift it left 7 units. If you put a -1 here, it would shift it right 1 unit. So that's how that works. We're going to see a lot of that going forward. So, okay, what's its vertex? So new vertex is at 3, 0. What's the axis of symmetry? Again, that's the line that splits it down the center. It's no longer at 0. Now it's x equals 3. It's actually always just equal to whatever the x coordinate of the vertex was. So because the x coordinate was 3, it's going to be x equals 3. When it was 0, it was x equals 0. So it's a really easy way to identify your axis of symmetry. The domain is different now. Since we shifted everything to the right 3, the domain is now from 1 to 5. And then also, if you think about it, the range doesn't change because when you just shift it left to right, we didn't go up or down at all. So it still just goes from 0 to 4 for the range. So the main kind of takeaway here is noticing how the different shifts affect the domain and the range. If you shift it left and right, that's going to obviously affect the domain. If you shift it up and down, like this one, that's going to affect the range. And that should make total sense to you because those are the x's and those are the y values. Okay? Any questions on anything with that so far? Okay, so basically the things you want to remember right now, if you add or subtract a number on the outside like this, it shifts it up or down. If you add or subtract a number on the inside, it shifts it left and right. But it does kind of do the opposite of what you'd expect. A negative does go to the right, whereas a positive would go to the left. Okay? All right, the other thing we're going to look at today is reflections. This, I think, is actually the easier of the two once it clicks. So this is, it says graph this function. So this is just a line. This is 2x minus 6. So remember that's like an mx plus b. So this has a y-intercept at -6, which you can see right there. And it's got a slope of 2. So it's going up 2 over 1. Up 2, right 1. Up 2, right 1. So we can see where that line came from. Okay. This wants us to graph this function, which is already graphed, and the function g. So that's what we're going to draw, which is this reflected over the x-axis. Then it also asks us, what's the equation? So we can do this a couple ways. First off, this is the x-axis. So when these points reflect over, they're just going to go to the exact opposite spot. So this point right here, when it goes to reflect over the x-axis, is going to end up here. Specifically, if it's 6 units below, it's now going to be 6 units above. So sorry, it's a little off the grid there, but that's where the new point would be. And another easy one to plot is the one that's already on the x-axis. Since it's already there, when it reflects, it's not going to go anywhere. So we actually know that this point is going to be part of it as well. And then from there, you could connect those, and you'd have yourself your reflection. Again, you did do that in geometry class, so that should look a little bit familiar to you. Now it says, how are their equations related? So we can now look at this, and we could come up with its equation, because it's got a slope of -2. It's going down 2 and right 1. So we could say, okay, g of x is -2x, and it's got a y-intercept of 6. So again, reviewing some algebra and some geometry concepts in the same exact problem here. But for a line, you should be able to look at it and say, yep, y-intercept is 6, slope is -2. I can write that mx plus b equation. Now, there's a shortcut to this as well, which feel free to use. I would personally use it if I were you. Anytime you want to take a graph and you want to reflect it over the x-axis, the rule actually is, if you take the f of x function and all you need to do is multiply it by -1. So if you take your f of x function and you multiply it by -1, that's going to reflect over the x-axis. So what does that look like when we do that? All that means is take whatever the f of x function was and multiply all the values by -1. So that's simply going to be -1 times 2x, which is -2x, and -1 times -6, which is +6. So notice, that's the same thing. So you can actually come up with the equation without having to do any kind of graphing if all you do is take, okay, if this is the graph I want to move, I multiply everything by -1, boom, now it's reflected over the x-axis. Really easy way to do that without having to make a graph, without having to do anything funky. Super quick, super easy. Okay? Any issues there? All right, so our last one is, how do you reflect over the y-axis? So we're going to do the same thing here. You'll notice this is the same exact line. This is the same exact f of x line. But now they say, draw the function g, that is this function reflected over the y-axis. Okay, so obviously y-axis is here. This is going to reflect over to this side. So I would just pick a point that's going to be easy, like this one. That's at 3. When that reflects over, now it's going to be at -3. And then for my other point, I would just take this y-intercept because, again, if it's on the y-axis, it's not going anywhere. So there is going to be our new line. And so we can just draw that in there. So that's the line g of x. This was f of x from earlier. So there's our line reflected over the y-axis. It is pretty easy to do graphically. Again, you did that in geometry. Now let's talk about their equations. So what's the equation for this line? Well, the y-intercept stayed the same, but the slope became -2. So the g of x equation is going to be -2x minus 6. So that's how you can do it graphically. But guess what? This one also has a shortcut, which is what I would recommend using. And the shortcut for this is you do f of -x. Okay? So what that means is all you're going to do is you're going to substitute -x into the function. So this is going to cause it to reflect over the y-axis. So what does that mean, or what does that look like? So if you take your f of x function and you replace any x's in here with a -x. Okay, so that's going to be, you would have 2 times -x minus 6. That's what that would look like when you substitute -x in. Just rewriting that so it looks a little cleaner. 2 times -x is the same thing as -2x. And you'll notice, of course, that is the same thing that we came up with originally. So this gives you a way to find that equation without having to actually draw the graph. So to kind of recap those two, if you want to reflect over the y-axis, you can substitute a -x in for all x's. If you want to reflect it over the x-axis, all you have to do is multiply the entire function by -1. So those are kind of your shortcuts, but also you can do it graphically. You can read graphs. You can do it that way as well. So that's what we'll cover today.